Good afternoon. It's my pleasure to welcome and introduce our keynote speaker for this afternoon, Stephen Hickson. Stephen has actually specifically asked me to undersell him so he can over-deliver. Within the last 5 minutes, I haven't been able to change my carefully crafted transcript here, so you are going to hear exactly all about Stephen. Stephen is Senior Teaching Fellow in the Department of Economics and Finance at the University of Canterbury. He writes academically rigorous articles on the frontiers of pedagogy. That would be great news for all of us. He believes the role of the university is to make people better thinkers. His teaching strategies include relating content to students' lives. Stephen presents ideas in multiple ways to help his students learn. He structures assessment so that students are guided into the behaviours that advance learning. Unsurprisingly, Stephen has a reputation as an exceptional lecturer. And this year he received an award for sustained excellence in tertiary teaching. Congratulations, Stephen. This afternoon, Stephen is addressing the significant challenges, you will pick them up from the screen there, and opportunities in assessment, a critical aspect of our work as educators. And I know I speak for all of us when we say we have huge admiration for our fellow educators in Canterbury in terms of the challenges they have faced, and we look forward to the insights you can share with us, Stephen. Welcome to the stage.
And thank you very much for having me. I'm very nervous because, well, actually, I'm sort of nervous. My wife says I never get nervous because when Jane actually contacted me a while ago, I said, what on earth would I talk about? What on earth could I possibly bring? And she said, well, just, bring something. All right, think of something. So I thought, okay, look, I'll try and bring something that hopefully might be of interest to people. I've got 2 or 3 things that we might do, but I'd like to also make this a little bit of a conversation. If you want it to be a conversation, I kind of feel that I'm way up here and you're down there, and that's not really kind of like, but never mind, that'll do. So if there's things that you want to stop and say, oh, what about this or that, then please feel free to do that, okay? And we'll see where we go. Maybe I'll get through everything, maybe I won't, but hopefully there'll be something in it for everybody. This comes out of some work that I did with my colleague who also teaches in the first year economics classes at the University of Canterbury, where following the June 2011 aftershock, we were forced to cancel a significant number of examinations because students were disrupted, the university campus was disrupted again. And so the university said, if you could cancel examinations, then that would be very, very good. Now, the crucial thing about this, as you'll find out, is that it happens basically on the eve of exams. Now, those images down there are actually from that June 13 aftershock. There's the dust rising above the cityscape on the left-hand side. Of course, by this time, the city is partway through the demolition mode, and the dust does rise. And over here you see liquefaction. That one on the right hand side is on the road out to Ferrymead, and basically the sinkhole opened up and the car got swallowed into it. So I have to say though, that I think that the view from outside Christchurch is that we're standing there and every 5 minutes we go, but it actually isn't like that. It's more like, people say there's been 2,500 earthquakes or something. Well, that's true. But there's 2,500 men's professional tennis players. How many can you name? Probably 4. Nadal, Djokovic, Federer and Murray. And that's really what it's like in Christchurch. There's 3 or 4 earthquakes which have done something significant, and the other 2,496 just recede into the hum in the background and are no worse than what Wellingtonians get every year either. So, in a way, I'd like to kind of just change that perception that we're just sitting down there going 5 minutes, because we're not, and nor are we teaching intense anymore. Right? That lasted about 3 weeks, but it was kind of fun while it lasted. I was teaching a class at 5 o'clock, 6 o'clock at night, because our timetable just got rearranged every week, and it's blowing in northwest gales. And so the tent is going, do you know how noisy it is in a tent? Right? And then in the northwest of the university is directly in the flight path of every aircraft. So anyway, yeah. So fun things, fun times, yeah, good times. Yeah. So, okay, what do we do then? Because this gives us a problem. Because examinations, of course, are important for a great many courses, right? Semester 1 was severely disrupted by a series of earthquakes. Everyone knows that, right? So the semester got off. We were on the second day of teaching when the February earthquake hit, right? And I remember ringing up my oldest daughter who was at school, but she was doing a course at university through the STAR program, and I rang her up on the cell phone. I said, "You guys are right." She said, "You were fine." And she said, "Will university be on today?" I said, "Actually, I don't think university will be reopening today." I didn't say for the next 3 weeks because I really only meant, I don't think today. It was 3 weeks. Anyway, 2 significant aftershocks occurred on June the 13th, 6 and a 5.5. And that results in the unexpected cancellation of exams. Now that's quite important because students, of course, have planned their life and behaviour around the expectation that they'll sit that exam. So we're now in a world where their study habits haven't been altered, just their assessment. Now, just to give you a little idea, this is just a wee clip. This is what a 6 looks like. Now, I'm at home at this time because we don't have offices. We're in prefabs now, but at this time we weren't, and so we were all mostly working from home. So I go into university when I needed to, and then I go home again. And I'm in my little office, which by now is a little desk about this wide, sitting between my filing cabinet and my running gear and underwear drawers. And that's my office now, right? And so that's where I am, and this 6 hits, and I think, oh cool, I've got to go around and video this. My wife thought that this was terrible. I thought, well, that's the first thing. And we've got a swimming pool in our backyard, right? And so, as quick as I could, I went out and I videoed it, because in the original September quake, we lost 1.5 foot of water out of the pool. And I'll show you why you lose it. So this is the video of the pool after I've actually gone around and got out to the pool and turned my little camera on and stuff, okay? So look at that there, you see that? What you can see there is the water essentially just flooding and you see the water going up and down in the pool? Now this is probably a good 30 seconds or so after the actual quake. There's 25 tonne of water in that pool, right? And it's just flooding the entire backyard, right? Isn't that amazing? So, you know, it is quite, they're quite significant events, right? And of course the university has to close and they have to check all the buildings, and so actually we're getting very good at checking buildings now. They've drilled all the holes in them, they can just go and look at them again, right? So that's kind of handy. So anyway, we're faced with this problem. We've now no longer got an examination. Now this is a problem because if you have the odd student who misses the exam, well, we all know how to deal with that. You say, well, okay, how would they have done given how their peers performed in the same exam? But we can't do that because nobody sat the exam. So what we did, we took 2 slightly different approaches. Now remember, we're making this up as we go along. So like, you know, maybe we should have planned for this, but who plans for everything, right? So in our 2 first year papers, we teach microeconomics and macroeconomics. We actually took 2 slightly different approaches. In microeconomics, what my colleague did, what Steve did, was he just simply transferred the weight of the final exam over onto the term test. So we had actually run term tests, and the interesting thing was there was a lot of pressure on us to not run term tests, right? And we fought and persisted, and in the end, it was a very good job that we did. In macroeconomics, I transferred the weight of the final exam across all of the assessment. So it's a mix of online assessment and an individuated term test. But the exam is worth 50%. So it's a substantial chunk, right? Interestingly, one thing that my colleague did do was he said, okay, of those students who don't get a passing grade, I'll write you a special exam. You can come in and sit that exam, and if you actually would pass that exam, I'll give you a C, the bottom passing grade, right? 155 students were eligible to sit that special exam, okay? only 21 actually managed to get up for a C. And of those, 8 were students who missed the term test, but were clearly good students anyway. So just shows you, doesn't it, that actually, there's some interesting things here. Okay, so what did we do? Well, we looked at this, we said, okay, what we want to do after the fact is we want to try and understand how good a job did we do in assigning grades, because that's what students care about. Students care about their grade. And we want to know how much did we mess up their grades by doing what we did. Now, we can't observe the counterfactual. We can't observe what they would have got in the presence of the exam, but we can actually do some simulation. And so we did. So a non-disruptive grade is a grade that all the student would get when they complete all the assessment as planned. Right? So they get the assessment schedule at the start of the semester and they do it all, and that's their non-disruptive grade. However it is that you choose to do assessment. Right? A disruptive grade is what the student gets when they can't complete the assessment schedule. In this case, it's a substantial disruption because you have to cancel 50%. Right? Now we can't observe this non-disruptive grade. Right? We can't see it, because of course they never take a final exam. But what we did was we examined different ways that we could have done this historically and say, okay, what would have been the impact on students, and we've modelled it effectively on the data that we've got, and we have a lot of data about our students, right? But the assessment over time isn't consistent. We have a lot of data about students going right back to 2005 for our first year principals classes, but the assessment changes. We've had an assignment. We then moved to online multi-choice tests after a period of time. In microeconomics, we've recently introduced some progress tests, which is online, and marks for tutorials. In macroeconomics, we made a change to the online multi-choice tests at this point here in 2009, where they were changed from being open for the semester to opening and closing around the window of time we cover the topic. That makes a bit of a difference to some things. And then in 2011, we introduced marks for the tutorial here. And we've maintained a pretty consistent term test final exam, but we have altered the weightings on those over time as we've introduced and changed other forms of assessment. So it's a little hard because we haven't got this wonderfully consistent set of time series data for students, which you might find odd from economists. We love time series data. And, but we haven't got that. But we've got something pretty close, right? So we can go back and say, okay, how might we understand what we did to students' grades, right? So what we did was we said, okay, what's been consistent? Well, we're going to focus on the things that we've got. We focus on using the online multi-choice quizzes and the term tests. Now, 2011 was the first time we'd introduced marks for tutorials, right, where they do some online work for tutorial prior to coming to a face-to-face class. So we don't have that. So what we did was we said, okay, let's imagine that we have some online work and some invigilated, and an invigilator piece like a term test, right? We give it to students who didn't sit final exams or term tests in the historical data because we say, they didn't complete all of the assessments, so let's just get rid of them. That gives us 8,752 observations, which is a lot of data to work with. What we can do then is we can calculate disrupted grades. We can go back and say, right, let's imagine that we cancelled the final exam and we therefore shifted the weight of the final exam onto the other assessment items for those students, right? And we can fiddle around with the weightings and say, what if we'd applied more of it to the online work? What if we'd applied more of it to the invigilated test? And we can fiddle around with that. What we can then do is say, okay, for those students in our historical data, we can calculate a theoretical disrupted grade, what they would have got if we cancelled the final exam. But we know their true grade. We know what we did give them. Now, we weren't trying to address whether our testing mechanisms were efficient or effective or measured learning or anything like that. We were taking as given the grade they got and said that is the grade they got. How would that compare to the grade that we would have given them? Now, the nice thing about that is that we can now examine the impact on individual students as opposed to distributions. because distributions hide things. So when people talk about, oh, we've shifted the mean or we've changed the distribution, that's great, but how did that affect, how did that affect Sally Smith? What about her grade? Because she doesn't care about the distribution, she cares about her grade, right? And Mr. and Mrs. Smith, who are paying for her education, care about Sally Smith's grade. They don't care about the distribution either. So that's what we wanted to get at. So we wanted to be able to say, what would we have done to individual students? All right, because that's what they care about. But one issue that we're going to have to deal with here is, of course, that different assessments have quite different means. So what you can see here is that the online multiple choice tests, the mean for those is about 76% in our historical data. Right? Now they're basic, simple online textbook quizzes that we give them. And what we normally do with these is we say, you can have as many attempts as you like at each test, and your highest mark counts. It's a random draw of questions from the textbook bank. That's all. You get 10 randomly drawn questions. You can attempt each quiz as many times as you like. What's the point of that? To get them reading the Jolly textbook and knowing the basic facts, right? That's the how do you spell crocodile question, isn't it? Right? And that's all we're really doing. And we give them a small amount of credit, 1% per test, and basically we're saying to them, look, we're just getting you to basically do some basic knowledge gathering, right? Well, of course, the mean's going to be quite high because they can repeat the tests, and we also quite openly tell them, why don't you get together with your mates and have a multi-choice party on a Saturday night? I don't think many of them do, but we say to them, we don't think that's cheating. We think that's learning. So the mean is high, right? The term test, typically the mean is only just over 50%, and the final exam's a little higher. They tend to be a little less time constrained in the final exam. So we've got a problem here. If in fact you move entirely to assessing the grade on online material, then you're going to bias the grades upwards, pretty much, right? Bias the grades upwards. But what we can do is say, all right, what happens then if we said, let's scale all the grades to some sort of historical distribution? We could do that, couldn't we? We could say, well, normally we only give out 10% of A's and 20% B's and whatever, right? And we could say, well, regardless of the mark we might give you, we're going to scale to that distribution. We could do that. We could do that, and that would then get rid of that upward bias in total. Of course, it wouldn't help Sally Smith necessarily, right? So we still want to care about the individual student, but we could get rid of the total bias by scaling, simply, right, to some sort of distribution we like, right? And we do model that, right? Okay, so what does this big, horrible, ugly-looking table tell us, right? Now, you don't have to absorb every number, but there's a picture that I want you to absorb, right? A picture I probably could represent better with colour, to be fair. Over on the left-hand side is the weighting scheme which says, right, we're going to apply no weight to the multi-choice tests. We're going to put all the weight on the term test. What do we do to the students' grades? Well, down here on the left-hand side is the change in their GPA. Now, we just simply assigned an A+ was worth 9, an A is worth 8, and many of you use the same GPA scale as we do? I don't know. An A- is 7, right down to a D being worth 0 and an E being worth -1. Okay? So it's just a GPA type thing. And then we said, right, we know what that is for your true grade. What about the grade we would have given you if we cancelled the exam? And we can just take the difference. And if you look here, what you see is 31.9% of students under this weighting scheme would have got the same grade. Their GPA change would be 0. Right? But there are many students whose grades have changed substantially more. In fact, 0.1%, not many, 0.1% of students' grades go down by 7 GPA points. In other words, they go from something like an A to a D. Now, how does that work? Well, there are in fact students who do very well, of course, on the online multiple choice tests and don't do well on the term test. And there's a reason why we can think about why that might be. Of course, they get the textbook in front of them with the online quizzes, and they've got their mate beside them, who's going, oh, I don't think it's B. You should pick C. All right, I'll pick C. Look at that, I got it right. But they didn't really understand it. So they do well on the online stuff, but they get found out in the term test, so their mark will go down. There are other students whose mark goes up dramatically. A 6-point change in their GPA. Why is that? Because there are a small number of really good students who can't be bothered with the 1%, but are good. And so they'll do very well in the term test and the final exam. They'll clearly pass the course. Are they worried if they get a B plus or an A minus? No, they don't care about that, right? They're getting a B plus in economics and an A plus in drinking. And so therefore, their life is balanced and happy. And they're not spending Saturday nights at home doing online quizzes for goodness sake, right? So in this world here, right, they do okay, all right, they do okay. So, and then what we do across the top here is we slowly increase the weight on the online quizzes until we get right over here and we put all the weight on the online quizzes and we have no invigilated assessment at all. Now look at what happens across the here. For a start, the number of students whose grades are unaffected falls as we raise the weight on the online quizzes, right? So we're getting a much greater disruption to grades. And look at the spread of the numbers. The height of that bar of numbers tells you how far we've now spread students in terms of disruption. Because we're going from -10 to +10, that's a big change. A -10 would be going from an A plus to an E. And we do have not quite any of those here, but we do have some students going from E's to A pluses if we put all the weight on the online quizzes. So that clearly wouldn't have been a good strategy for us, right? So if we had to cancel the term test and then rely entirely on online work, some students who would have failed would now get A's. And so that's probably not a good strategy. Down here we can see some summaries. If we look at the percentage of students whose grade is changed by -1 or +1 in terms of GPA, so they B plus now B, or B now B plus, okay? And you look across here, it's not too bad. 60%, 73%, 65%, but by the time you get across here, only 26% of students are in that narrow band. Plus or -2, the results are better, of course, because we're allowing a bit more. But for this weighting scheme here, 0.2, 0.8, 92% of students, so that's not too bad. But over here, it's only 39% of students who lie in that plus or -2 band, and the rest are disrupted a lot more than that. So that was the first thing that we found, right? What we then did was we said, okay, let's scale to historical distributions, because we want to get rid of that problem we've got where the means of the assessment items are different. And you do get better results here. So if you have a look, we raise the numbers that sit in these narrow bands, more or less, right? We've raised the numbers. So it looks like scaling might help us get less disruption from this sort of exercise, right? It looks like it. So that row is quite crucial. Let's put those two together, you see? When we take, say, this one here, where we've got no online work and it's all on the term test, we raise the percentage of students who are in the +/-2 from about 81 up to about 89. So it looks like scaling actually reduces the disruption, which we might expect, okay? Similarly, across here, we've raised from 91 to 92, 85 to 92, 64 to 86. And here we've had the biggest effect. We've raised from 39 to 69. In other words, now 70% of students sit in that +/-2 range, because we've taken out a lot of the variability in the scale. So you might look and say, scaling helps, but we'll come back to it. So what are the key points at this point? Well, if you're going to rely completely on online quiz works, it's likely to produce substantial grade distribution when the thing that gets cancelled is an invigilated piece of work, right? That's what this is telling you. That if you're relying on, if your exam is a big part of your assessment, and it gets cancelled and you have to move entirely to online type work, you can expect some substantial grade distribution. Sally Smith's grade may well be very different than what she would have got with an exam, right? It could be up, it could be down, okay? The grade inflation rises as you in fact apply weight to the online quizzes. Let's just go back here. Here's the overall change in grade point average. So this is the average change in grade. Here, grades are down by 0.8. So that's one grade point nearly. Here, grades are actually unaffected, or the average is about the same. Over here, grades are up 3.4 percentage points. In other words, we've raised the average grade from, say, C plus to B plus. Now, that's a big signal for students, isn't it? If you get a C or a C plus on a course, the student's sitting there thinking, gee, you know, this economics, is it really for me? I'm not sure. But if you give them a B plus, then they're thinking slightly different. So this has certainly raised the grade. Okay? But we can remove that grade inflation by scaling, and we did. If we didn't do it in practice, in our simulation. Okay? So you can remove the grade. Now then what we said is, okay, what about 2011 semester 2? Because that was unaffected by any shock, right? It's also the only semester in all our data where the assessment items are identical to semester 1. And so we said, let's imagine that we have to cancel the assessment, their final exam in semester 2 again. And of course, we're all sitting there on the eve of the final exam and we're going, no, come on, get on the way with the final exam, come on, so that we can actually have a final exam. But we said, let's imagine we had to, right? Let's imagine we had to. Let's simulate that. So we did. So this here is what in the first set of simulations, we were doing something close. Here we did exactly what we did in semester 1 because we had identical assessment items that we could do it with. And we found something very interesting here. In the micro course, we said, right, using raw scores, not scales, right, what do we get? Well, we would have had, compared to what they actually got, a small rise in their average GPA if we had to cancel the final exam. 87% of students, though, would have been in the plus or minus 2 range. But 13% of students would have had their grade disrupted by more than that. Right? Is our simulation. If we scale to the historical distribution to try and get rid of any sort of, you know, other effects we want to like, interestingly enough, we lower the grade by 1.5% GPA points, and the numbers of people in those narrow disruption bands fall. Scaling would have turned out to have been a bad idea. Right? And I'll think about that why in a moment. Over here in macro, we said, okay, let's pretend that we had an exam cancelled and we did exactly the same thing. Well, students would have got, on average, a slightly lower grade than they actually got. But a large number of them would have fitted within that plus or minus 2, about 95%. So that's actually not too bad. 95% sitting within that plus or minus 2, not too bad, right? Well, both approaches perform well compared to the historical simulation. And that's what we would have hoped. Overall changes in our GPA were about what we would have expected. So we're feeling sort of pretty happy that what we did was not too disruptive. What was the deal with the scaling? Because you would have thought that maybe scaling would have made it different. Well, here's the problem with scaling. What we did was we said, let's take some historical set of distributions, right, that we know. And you might think that 6 years worth of grades in your course should give you a pretty robust sort of distribution to scale to. Because the cohort can change. And what we had in the space of about a year was a bunch of engineers switching semesters. You see, up until very recently, up until this year, engineering students in their 4th year were able to take first-year electives, right, as part of their course of study. Now, these engineering students are very bright students. They're really good students, especially compared to the average first-year incoming student, right? And they come in, and they always do very well. Well, imagine what happens when they switch semester. They change the distribution. Now, the distribution, you might think, oh, surely the students in semester 1 are the same as the students in semester 2 because we run micro both semesters. Well, no, they're not. Here's why not. In semester 2, we get the failures from semester 1 repeating the course. And they are overwhelmingly likely to fail again. Only 50% of them actually manage to raise their grade. And even then, they barely raise it much past about a C plus or a B minus. So the distributions are in fact not consistent over time. And that's what you have to worry about, is that cohorts are actually remarkably different because of these changing natures of how students are coming in and going out and doing things and so on and so forth. Well, we then said, okay, it just turned out that my colleague and I did slightly different things. He took all the weight from the final exam and put it on the term test. I spread it evenly. Which one of those approaches would be better, right? Because he had 87% of students in the ±2 range when we simulated it in semester 2. I would have had 95, right? So maybe my approach of spreading it over everything was better, okay? Well, that's what we did then. We said, let's reverse them. Let's pretend that in semester 2 we cancelled the exam, but he and I switched approaches. And when we do that, we find something interesting, right? That in actual fact, the percentages in this narrow band here go down for both micro and macro. Now you would expect, right, that if the spread evenly approach was better, we'd expect the results for micro to improve, but they didn't. If, in fact, allocating everything to the term test was better, we'd expect the results for my course, macroeconomics, to improve, but they don't. Now, the only thing we can put this down to is pure dumb luck. Right? Well, actually that, or some sort of stroke of brilliance on the behalf of both my colleague and I. But I think we're probably just going to go for the luck explanation, quite frankly. It just turned out that we probably picked for both of our courses an approach which worked better. But there was no rhyme or reason. And maybe that sort of comes down to the intuition thing that I think that, you know, that sometimes you just know. And can you explain it? No. And maybe if we did this again, we'd get a different result. I don't know. We're not sure how much credit we should actually take for that stroke of genius, but there it was. So what we couldn't find was that there was any conclusive evidence that one approach was better than another. But here's what we did find. We find substantial grade disruption and grade inflation as the weight applied to online tests and other work rises. Where you are, remember this is contingent on an invigilated exam having been cancelled, right? We find grade inflation and grade disruption. So not only do average grades rise, which is what you'd expect, but individuals are badly affected too. So Sally Smith might have got an A, now she gets a C+. Or maybe she got a C, would have got a C+, now she gets an A, right? Grade inflation can be removed, that's true. We can scale to some historical norm, but the disruption is still significant at an individual level. We can remove the mean disruption, but we can't remove the disruption entirely to Sally Smith. She still cares about her grade, right? So that doesn't get us around the problem. And also, it leaves you with the additional problem, which is if your cohort of students is changing, you can't be sure that the distribution that you're scaling to is actually any better than what you might have got just using your raw numbers. We didn't find any strong evidence that supports the use of either of the two approaches, spread evenly or allocate entirely to the other invigilated piece of assessment. But what we did feel was that if in fact you have one piece of invigilated assessment, then it's probably actually worth having two. Now, I know that, you know, people might say, well, you know, should you plan for that? I think that in the environment that we're in, we found that useful. We found that very useful. And probably most people around New Zealand are thinking, well, we're unlikely to face a campus closure of the same magnitude. I don't know that's true. I think it's focused, in Canterbury, it's focused as a little bit more on the sort of things that might close a campus. And other campuses around the world, interestingly enough, go through, they will actually close part of a campus as a trial, you know, and they'll say, well, what would happen if this happened? If there was a norovirus outbreak in part of the campus and we couldn't use it, and so that was what those sort of summary things that we found. A little earlier this year, Melbourne suffered a very small earthquake. It was just laughable to see. Do you remember this? Do you remember Melbourne getting this earthquake? And we're all sitting over there. You know, I mean, it's funny that house up there is, it's above, if you walk down Sumner Beach, it's where, it's just past the causeway. No, it's further in. Yeah. It's where? It's where it's
just for check.
just for check. That's
about the check.
near check rock. It's near shag rubber. Shag rubber. Yeah, shag hollow. That's right. And you can see up the top there the houses hanging off the cliff. Those houses are literally just hanging off the cliff. That's what they're up there for. It is quite funny. My youngest daughter was 11 when this is kind of relevant but funny. 11 when the first earthquake hit, and for the first 3 weeks after that she slept in our room and mattress on the floor. Then she went back to her own room, but I had to sleep with the mattress on the floor in her room. And then finally I went back to my own room. Well, and she was, for the first quite a long time, anytime anything happened, she was under a door frame or whatever, or under anything she could find. Now, if we get a shake, it's like she just sits there, carry on playing with her iPod, and says, if it ain't a 6, don't get me out of bed. So that was what we were trying to get at, and hopefully maybe there's something. Any questions or comments at this point, and then we'll do something a little different.
Sorry, just to clarify, when you applied the scaling, that was on the data without having changed the distribution of the weightings?
Yeah.
So it wasn't scaling and...
No, what we did was we'd say, all right, let's simulate what would have happened. Let's assign the grades to the students. Now, historically, we might know that the top 5% of students get A+, the next 5% get A's. So what we'll do is we'll assign them a mark, and then we'll essentially say, right, we're still going to give the top 5% A+, irrespective of their mark that we would have given them. We'll scale to that. And it turns out that you can get rid of the mean disruption, but you don't get rid of individual disruption, and you can, in fact, make matters worse when the cohort's changing. That's what we found. Interesting. Yeah. Yeah.
How many years have you worked it out?
It was our summer project last year. Yeah. And there's a lot of I'm a bit of a data geek really. I spent 14 years working for Statistics New Zealand, and so and so yeah, it's true, right? If you're the sort of person who has labelled coloured containers in your garage for different size screws and nuts and bolts, I'm the sort of guy that does that with his data. So I have all of my assessment data going right back to 2002 in the same format. And that meant that I could actually easily do this. So there's a lot of data crunching going on behind here. Yeah, a lot.
What sort of reflections did you have about the forms of assessment?
Yes, that's a good question. We were very clear at the start of the project, and we did, this is a paper that we have had this published, that we were not, our aim was not to try and talk about efficacy or efficiency of various assessment measures, because we were not able to measure that with the data that we've got. So we didn't set out to do that. We took as given that the grade that students got historically was simply a fact of life. And what would we have given them in an alternative world? So the grade they got was the one where they completed all their assessment. Now, in terms of behaviour, students, of course, assessment drives behaviour, doesn't it? And the crucial thing about this was that the exam was cancelled on the eve of the exam, so they hadn't had time to adjust their behaviour, which is a different world than if you say, look, the exam is voluntary. So we didn't set out to try and measure the effectiveness or otherwise of the assessment, but to simply compare the grade they did get, something we took as given, versus what we might have given. It's probably not helpful, but we didn't do that effectively, is what the answer is. Yeah?
So can I ask a sort of a related question? Because one of the things I get a lot from my colleagues is the internal assessment predicts the exam result, really well, which may or may not be the case. Is there a way to draw some conclusions on that?
Well, you could do this by, in fact, you could run regressions on this sort of stuff, and on the left-hand side, you could have, your exam score. On the right-hand side, you could have all the other things. And I've got some work, I have done some work on that when it comes to different question format, on multiple choice, constructive response type things, and how well they predict, each other and that sort of stuff. I would say that what we tried to do here was get at grades. So the reason why we did that was because we could have said, right, how well does the online material predict the final exam score? And we would have got a statistically significant coefficient, right? And it might have been a statistically significant coefficient of an R squared of 0.8 or whatever. In other words, a very good fit. But that doesn't tell you about Sally Smith. And that's what we were after, you see, because, and that's why we tried to move away from that sort of prediction type of approach, because you're then dealing with distributions. And we wanted to try and get it, well, okay, but we care about Sally Smith. How would her grade have been altered? And what are the number of students who would have experienced a substantial change in grade? But you could do that approach too. Yeah. And no doubt it's statistically significant. I'm dead sure of that. Yeah, 100%. Any questions or comments at this point, and then we'll do something a little different.
Sorry, just to clarify, when you applied the scaling that was on the data without having changed the distribution of the weightings?
Yeah.
So it wasn't scaling and...
No, what we did was we'd say, all right, let's simulate what would have happened. Let's assign the grades to the students. Now, historically, we might know that the top 5% of students get A pluses, the next 5% get A's. So what we'll do is we'll assign them a mark, and then we'll essentially say, right, we're still going to give the top 5% A pluses, irrespective of their mark that we would have given them. We'll scale to that. And it turns out that you can get rid of the mean disruption, but you don't get rid of individual disruption, and you can, in fact, make matters worse when the cohort's changing. That's what we found. Interesting. Yeah. Yeah.
How many years have you worked it out?
It was our summer project last year. Yeah. And there's a lot of... I'm a bit of a data geek, really. I spent 14 years working for Statistics New Zealand, and so And so, yeah, it's true, right? If you're the sort of person who has labelled coloured containers in your garage for different size screws and nuts and bolts, I'm the sort of guy that does that with his data. So I have all of my assessment data going right back to 2002 in the same format. And that meant that I could actually easily do this. So there's a lot of data crunching going on in behind here. Yeah, a lot.
What sort of reflections did you have about the forms of assessment?
Yes, that's a good question. We were very clear at the start of the project, and we did, this is a paper that we have had this published, that we were not, our aim was not to try and talk about efficacy or efficiency of various assessment measures, because we were not able to measure that with the data that we've got. So we didn't set out to do that. We took as given that the grade that students got historically was simply a fact of life. And what would we have given them in an alternative world? So the grade they got was the one where they completed all the assessment. Now, in terms of behaviour, students, of course, assessment drives behaviour, doesn't it? And the crucial thing about this was that the exam was cancelled on the eve of the exam, so they hadn't had time to adjust their behaviour, which is a different world than if you say, look, the exam is voluntary. Yeah. So we didn't set out to try and measure the effectiveness or otherwise of the assessment, but to simply compare the grade they did get with something we took as given versus what we might have given. It's probably not helpful, but we didn't do that effectively, is what the answer is. Yeah.
Steve, can I ask a sort of a related question? Because one of the things I get a lot from my colleagues are the internal assessment predicts the exam result, really well, which may or may not be the case. Could a way to
I mean, you could run regressions on this sort of stuff, and on the right, on the left-hand side, you could have, you know, your exam score. On the right-hand side, you could have all the other things. And I've got some work, I have done some work on that when it comes to different question format, on multiple choice, constructive response type things, and how well they predict, you know, each other and that sort of stuff. I would say that what we tried to do here was get at grades. So the reason why we did that was because we could have said, right, how well does the online material predict the final exam score? And we would have got a statistically significant coefficient, right? And it might have been a statistically significant coefficient of, like, you know, an R squared of 0.8 or whatever. In other words, a very good fit. But that doesn't tell you about Sally Smith. And that's what we were after, you see, because, and that's why we tried to move away from that sort of prediction type of approach, because you're then dealing with distributions. And we wanted to try and get it, well, okay, but we care about Sally Smith. How would her grade have been altered? And what are the number of students who would have experienced a substantial change in grade? Yeah, but you could do that approach too. Yeah. And no doubt it's statistically significant. I'm dead sure of that. Yeah, 100%. Well, there's probably more time in here, but now what I'm going to do is just do something a little bit different. Now, there are thousands of ways to, in fact, get at this. And I was at the really, really neat iPad presentation just before lunch, which was really cool. And there's just loads of ways to do this. This is just one, and I just thought I'd bring this along. Some of you would have got a little wee green thing. I'm sorry I couldn't bring more. I've only got about 20. I spread them around. Why haven't I got as many? Because I couldn't afford another bag without having to check in luggage. Is the truth. So, we're just going to look at some of the things here. Right. Then they'd arrest me as a terrorist, wouldn't they? You know? Oh, what's that you got there? Yes, yes. Why you're looking rather bulky. Those look like Patrick Syntax or something here. What you need to do here, if you've got one, is turn the clicker on at the bottom and then key in this number 33. Now, when the clicker turns on, the little double arrow light will flash very quickly. Right? Now, I do use these in class, yeah?
Just wait a minute, the sheriff now is there.
Do you think this was another one of those conference freebies? So, what the screen is telling me is that 6 of you have joined. Now, our university has a stock of these, and you basically just get them out of the pool. The biggest hassle with me, I find, is that if I've got 300 or 400 in a class, is getting this many to class, so I typically tend not to bother. I use them in anonymous ways mostly, but a colleague of mine, if you turn over the back, you'll see that there's a little wee individual number on them. You can actually issue them to students and then record who's got them. I use them anonymously. So key in the number 33. When it logs you in, you'll see that you'll get a little green tick, and the double arrow light will flash very slowly. So slowly you'll think it's turned off. It hasn't. Okay? All right? And all I'm going to do is just share with you some ways that I found them helpful, and if it's helpful for you, great, and if not, no. You've got it now? Okay. Now the thing about these clickers is that, and there are only one solution to getting feedback and information from students, but it does integrate with PowerPoint. So you can actually write your questions within PowerPoint, and the clicker software is an add-in to PowerPoint. So it's all done within PowerPoint. So I'm just running these as slides. Okay. You don't need that. Right. Okay, so some things I do is just opinion type questions. So here we go. Those of you who've got clickers, you've got 30 seconds to answer this. The countdown is on. If possible, countries should be self-sufficient in food production. 1 strongly agree, 5 strongly disagree, 2, 3 or 4 in the middle. You've got 15 seconds. You can set the countdown to whatever you like, incidentally. I just want to put the pressure on. Okay, and you see it's telling me how many people have entered? How many people there? Now I can stop this question when I like, or I can just let it run down. Okay, and there we go. So 5 people strongly agree, 7 people agree, and 3 people disagree, okay? And then we can start a bit of a discussion about that, you know? And the interesting thing that I find from students' perspective, whenever you do anything like this, is, it doesn't matter what the school is that students look at that and they go, but some people don't think like me. And that's the second thing they usually think. But it's that realisation that some people don't think like me. And it gets around this, right, who strongly agrees? And the student goes, and they look around to see who else is answering, right? And they're not sure. So it gets around that, right? Okay. Sometimes I'll use it to assess what students have learned after an exercise in class. So I'll give them some work, and then they'll come back, maybe do it in groups or whatever, and give them some questions, and we'll find out what they know. So, I mean, you haven't done the work, so you wouldn't know the answer here, but this is the idea. They've gone away, they've had an article, the consequence of the move by OPEC is that, and this is a basic supply and demand type thing that I do a little bit actually with my MBA class, and they come back and they, because they've got a nice basic supply and demand, and away they go, right?
Where's the don't know button?
Don't know.
Yes.
Just press number 1.
And so it then gets, I then can look, and when I get their answers, let's have a look. Right? So the correct answer is in fact number 2. And I say, well, we've clearly got an issue here because 10 people chose number 4. If everybody chose number 2, then we could say, great, we've got that, and we can move on. So that's kind of helpful. Well, here's another one. See if you do know this one. You buy a house next to a noisy motorway. Is the noise from the motorway an externality? Yes, no, or don't know. Now, I'll just shift this down here because then you can see the definition. An externality. If you don't understand what if this looks like one of those math problems which says, I have 10 ice cubes, you have 4 pink hats, how many pancakes fit on the head of a purple? It sounds like that, and put what you like. Right? Put what you like. Alright, let's see. Well, the correct answer is actually 2, in fact. Now, for those of you who wonder why that is, it's not really about externalities. You paid less for the house. That's the answer. The motorway was built into the price of the house. Or, right, survey type questions. Okay. Females only out there. Let's answer this one. Let's see. Females only, please. No males. How much do you pay for a haircut? If you're a male, hand it to a female next to you if they will answer it, okay? How much do you pay for a haircut? Alright. Right. So, any answer is correct. 14 of you pay more than 40, 3 of you pay between 25 and 40, and 1 of you pays between... Nobody pays nothing. Right?
Is that number 3? Stand up, please.
Males, how much do you pay for a haircut? Males, how much do you pay for a haircut? Males. Now, there's no way you would get a group of students to give you this result. If you're the female or the male sitting in the audience and you pay $120 for a haircut or whatever it is, and that's fine by me, that's your choice. But they're not likely to put their hand down. Right. Okay. Now, that's a different distribution. And it's a really cool question. I actually have a follow-up question which goes, I would let my flatmate, brother, uncle, flatmate's friend cut my hair, yes or no? And I asked males and females of that, and I get a virtually bimodal distribution. Males, yes, females, no. And it's a great question because it allows me then to launch into an interesting topic, which is why do females pay more for haircuts than males? Now, I don't now have to establish that in fact females do pay more than males for haircuts. I just did. Now, it's not a scientific survey, but I guarantee you, every time I run this, I get exactly the same result. Different distributions, but always females are paying more for haircuts.
It's not a cut, it's a style.
Right. Of course, sorry. My bad. Right. You see, my idea of a perfect haircut is one that takes place in 7.5 minutes. Right? Don't give me this all this. They hate when you go like just the cut, please. But it's great because I can then start, and we can then go on to the topic, which is, I mean, this is economic. Why is the price of female haircuts more than the price of male haircuts? And it's great, and we then have a discussion about it. There's always males who talk about, you know, they say, oh, female hair is longer, and there's always a female in the class who's got hair here, and says, but I don't. So it's great. It's great. I won't go into why they do. This one was interesting. I took the clickers to class one day, 2 or 3 years ago now,